Welcome to Khetztutorials, and in this video I'll just be continuing with probability. But now specifically I want to talk about, or I want to go through a few examples which are related to part 1 of this probability series. So I'll link that video on the top right. If you haven't watched that, I do advise that you go watch that. So before we go into the examples, I just want to talk about a few more things which I didn't mention in the video. And one of them is, if you given a probability in terms of a percentage, let's say for example you have the chances of something happening given to you as 20%, then basically this is equivalent to 20 over 100, which you can write as 0.2. So all the way at the extremes you can view this as 0% and that as 100%. So in between, then you just have these fractional parts that you have. So that is one thing that I want to talk about. And the other thing is basic terminology. So they'll always use some sort of words which basically describe what they're saying. So you won't always get this given to you, but the question can actually mention this exact same thing by using words. So for this, you'd have both A and B. So the word would be both. So that would tell you that you're talking about the probability of A and B happening at the same time. But another word would be either. Now, when you talk about this word either, then you're basically referring to one or the other. So it can be A or B. So the probability of either A or B occurring, and the negative or the opposite of this would be neither. So basically the probability of not A or B, right? So this is something that you have to look out for, and I think I have one question that actually highlights the importance of these terms. So let's go right into the examples. The first one, you're given the probability of A as 0.3, the probability of B as 0.5, and you asked to find the probability of A or B. So what is the probability of A or B if A and B are mutually exclusive? Now, what do we know about mutually exclusive events? Well, basically they don't have an intersection, or mutually exclusive events can't happen at the same time. This is what you have to know. Don't forget that. When we say that events are mutually exclusive, they can't happen at the same time. But again, from the addition rule, what do we know about this, or what can we find using this formula? From the addition rule basically says P, A, or B is equals to the probability of A alone plus the probability of B alone, and then subtract the intersection of the two. But now, if these events are mutually exclusive, there is no intersection, which means this holds and that thing over there is just 0. So this is just 0. So we can discard this completely. So it's helpful to us to know what this actually means. So we know that this is 0, so we only have to focus on this portion of the question. And we have these values we just have to add. So once you understand probability, or once you understand what is actually going on, you'll only just do basic addition and multiplication and probability. So it's important that you know the background information so that all of this can basically be easy to you. So the result of that would be 0.8, and that is your answer. The next example says, if you have the probability of A as 0.3, the probability of B as 0.5, and you're given the probability of A or B as 0.65, then what is the probability of the intersection, or what is the probability of A and B happening at the same time? Now, once again, we're going to use the addition rule, and we aren't specifically given any other information, so just use the addition rule as it is. And it's important that you know the addition rule so that you can write it out and actually show that you know what you're doing. And what we're looking for is this thing over here. So you can make that the subject of the formula by taking it to the other side and then taking this to this side of the equation. And that will give you PA and B equals to PA plus probability of B, then subtract this, which we took to the right hand side. And once again, we have all these values given to us in the question: probability of A, probability of B, and probability of A or B. We have all of that, and we can just substitute. So the probability of A given to us is 0.3, probability of B is 0.5, and we're going to subtract this value. So we can finally have the probability of A and B. And from the previous question, we found this value over here, which is just 0.8, and 0.8 subtract 0.65 should give you 0.15. And that is our answer. So just use the addition rule to find this value over there. Moving on to the next example, example number 3. So this is the second last example that I only do 4 examples. So now let's look at this example over here. And in this one, the terminology is particularly important. Even though I'm basically writing this in terms of the notation that we now know, it was actually given in words. And this part is perfectly fine. It's easy to take this part. But the next part, which is particularly important, I'll basically just say in words and then write or try to reason with what the statement is actually saying. Now, the next statement basically said the probability of neither R, so this is R, this is Q. So we have 2 events, R and Q, right? So this is an R, even though it doesn't look like it, but it is nevertheless. So we have R and Q. And we are told that the probability of neither event occurring, so neither occurring, that is what we're told, is 0.1. So now the question is, what does this mean? So basically told that the probability of neither R or Q occurring is 0.1. Now, if you remember what I said at the start of the video, I basically said if you have either, then you're basically looking at one or the other. But now we're told that neither of them actually occur, then we should be looking at not A or Q. We're talking about R, not R or Q. So in that sense, this is what they're basically giving us. They're giving the probability of not R or Q as 0.1. But then what is the question asking for? The question then asks for the probability of R and Q occurring at the same time. So how then would you find this probability, or how would you go about calculating this? So remember that we talked about complementary events. And remember that we talked about this fact that if you have an event happening, if you add the probability of that event not happening to the probability of it happening, then you basically expect to get 1. So if we don't have R or Q, then we expect to have R or Q. Right? So this is the first step, and the reason that I'm doing this is in the question we're given the probability of not R or Q. But remember, in the addition formula or in the addition rule, we basically use this. So the first step would be to find this so that we can then find what we're looking for, which is all the way at the end of this formula. So this is what we're looking for. We have this in the question, we have that, and we're looking for this thing over here. But also, we don't have this. So there has to be a way for us to actually find that value, and this is how you'd find it. The probability of R or Q occurring and the probability of these two not occurring should add up to 1. Because we either have these occurring or not. So you can look at this as two options, and if you only have certain options, then you expect them to complete the thing. Just like with a pizza, let's say you had a pizza or you had whatever which you can cut into pieces. Now, so the complete thing is made up of this piece, this specific piece, and not the piece. So the rest or everything else constitutes of an event which we can call not this piece. So now if we add the piece and everything which is not the piece, then we have a whole pizza, right? So that is the reasoning behind this. And now that we have 0.1 as not R or Q, then we can now find R or Q, and that would be 1 subtract 0.1, which is 0.9. And now that we have that is 0.9, we can put it into this formula and then plug in everything else that we're given in the questions. The probability of this would be 0.5, and the probability of that would be 0.6. So we put that into there. So 0.5, 0.6, and we want to find this. This is what we want to find. And once again, we can just move the stuff around, moving this to the left hand side, then moving the 0.9 to the right hand side. And this should add up to 1.1. Subtract that should be 0.2. And that is the answer. And that is how you'd go about finding the answer. So always keep in mind, or always read your questions and understand what you have been given exactly, so that you can see how you can get to the final answer. So the terminology or the phrasing of the questions is very, very important in this case. Now moving on to the last example. In this example, you're given the probability of A as 0.2, given the probability of B as 0.6, then the probability of A and B equals to 0.12, and you're asked, are A and B mutually exclusive? So let's look at A and B. Just trying to draw this right out of this. Are A and B mutually exclusive? And to answer the question, obviously you have to understand what the term mutually exclusive means. It basically means that A and B can't happen at the same time. But now, if you have a probability for them happening at the same time, then you know that they're not mutually exclusive. Because for mutually exclusive events, if A and B were mutually exclusive, then the intersection should be equal to 0. But now in this case, the intersection or the probability of A and B happening is not equal to 0. And therefore, they are not mutually exclusive. So you don't even have to calculate anything. You don't even have to do much. You just have to look at the information that you have. And if perhaps you are given this value, and you found that A and B were not equal to 0, and the probability of A and B was not equal to 0, then you'd make the same conclusion. But if you are given this, then later asked to find this, or later asked whether A and B are mutually exclusive, then you'd find this P, A and B. Then if that value was not equal to 0, then they're not mutually exclusive. And if it were equal to 0, then that is when you'd conclude that they're basically mutually exclusive. So that is how you check whether events are mutually exclusive or not. You check the intersection. If it's equal to 0, then they are mutually exclusive, and if it's not, then they're not mutually exclusive, which means that they can occur at the same time. So those are all the examples that I thought of, and these examples are particularly related to part 1, which I did. And in the next video, I'll just continue and talk about all the other things which are important in probability. So stay tuned for that. If you have any comments, leave them in the comment section or email me if you have anything to say. If you want to book a live session with me, once again, you can do that by email as well. And if you like this video, just give it a thumbs up. If you haven't subscribed, please subscribe, and I will see you in the next video.